Hi friends, welcome. This is the second part of the mechanical engineering competitive exams, theoretical questions and answers on engineering mechanics. So friends, let's begin. Friends, question 51 is, if a body is acted upon by a number of coplanar non-concurrent forces, it may option A is rotate about itself without moving, option B is move in any one direction rotating about itself, option C is be completely at rest, and option D is all of these. And here friends, option D is the correct option, that is answer for this question. So now next is friends, question 52. A smooth cylinder lying on its convex surface remains in dash equilibrium. Here friends, options are stable, unstable and neutral. Here friends, correct option is option B, that is unstable. Here friends, a smooth cylinder lying on its convex surface remains in unstable equilibrium. Now next is, three forces acting on a rigid body are represented in magnitude, direction and line of action by the three sides of a triangle taken in order. The forces are equivalent to a couple whose moment is equal to. Here friends, these are the options, and here friends, correct option is option B, that is twice the area of the triangle. Next, question 54. The principle of transmissibility of forces states that when a force acts upon a body, its effect is. Here friends, these are the options, and option C is the correct answer for these questions, that is minimum if it acts at the center of gravity of the body. Now next is, a smooth cylinder lying on a dash is in neutral equilibrium. Here friends, options are curved surface, B is convex surface, C is horizontal surface, and here right answer is option C, that is horizontal surface. Next is question 56. If three forces acting at a point be represented in magnitude and direction by the three sides of a triangle taken in order, the forces shall be in equilibrium. Here options are true or false, and here correct option is option A, that is true. Now next is 57. Two equal and opposite parallel forces whose lines of action are different can be replaced by a single force parallel to the given forces. Here options are correct or incorrect, and here option B is a correct option, that is incorrect. Now next is, two equal and opposite parallel forces whose lines of action are different form a couple. Okay, and here options are right or wrong, and here correct answer is option A, that is it is right. Okay, now next is question 59. A couple produces. Here friends, options are translatory motion, rotational motion, combined translatory or rotational motion, and option D is none of the above. Here friends, option B is the correct answer, that is rotational motion. Okay. Next is question 60. Which of the following statement is correct? Statements are, the algebraic sum of the forces constituting the couple is 0. Option B is, the algebraic sum of the forces constituting the couple about any point is the same. Option C is, a couple cannot be balanced by a single force but can be balanced only by a couple of opposite sense. Option D is all of the above. Here friends, option D is the correct answer for this question. Next is question 61. Match the correct answer from group B for the statements given in group A. Now friends, group A statements are, A statement. The statement, first statement is, the resultant of two forces P and Q, P is greater than Q, acting along the same straight line but in opposite direction is. And friends, here from group B, option B is the correct answer for this, that is P minus Q. Okay, now next is the resultant of two like parallel forces P and Q is, here friends, option A, that is P plus Q is the correct answer. Now next is the resultant of two equal forces P making an angle theta is, here friends, option D is the correct answer, that is 2p cos theta upon 2. And next is the angle of inclination of the resultant of the two forces P and Q with the force P is, answer is option C, q sin theta upon P plus Q cos theta. Friends, for question 62 and 63, consider this figure. Question 62 is the force induced in the string AB due to the load W as shown in figure is, here friends options are W sin theta, W cos theta, W sec theta and W cosec theta. Here friends option D, that is W cosec theta is the correct answer. Now next is the force induced in the string BC due to the load W as shown in figure is, here friends options are W sin theta, W cos theta, W tan theta and W cot theta. Here friends option D, that is W cot theta is the correct answer. Now next is question 64. The point through which the whole weight of the body acts irrespective of its position is known as, here friends these are the options, and here friends option B is the correct answer, that is center of gravity. Next is question 65. The term centroid is, option A is the same as center of gravity, option B is the point of suspension, option C is the point of application of the resultant of all the forces tending to cause a body to rotate about a certain axis, and option D is none of the above. Here friends option A is the correct answer, that is centroid is the same as the center of gravity. Next is an irregular body may have more than one center of gravity. Here options are yes or no. Here option A is the correct answer. The next is the center of gravity of a rectangle lies at a point where its two diagonals meet each other. Here agree or disagree. So here option A is the correct answer. Next is the center of gravity of a triangle lies at a point where its medians intersect each other. True or false? Here option A, that is true. Next is question 69. The center of gravity of an isosceles triangle with base P and sides Q from its base is, here friends these are the options, and here option A, that is under root of 4p square minus q square upon 6 is the correct answer for this question. Now next is the center of gravity of an equilateral triangle with each side A is dash from any of the three sides. Here friends these are the options, and here option C is the correct answer, that is A upon 2 root 3. Okay, now friends next is here the center of gravity of a semicircle lies at a distance of dash from its base measured along the vertical radius, and friends here these are the options, and here correct answer is option B, that is 4r upon pi 3 pi, sorry, 4r upon 3 pi. Now next is the center of gravity of a hemisphere lies at a distance of 3r upon 8 from its base measured along the vertical radius. Options are right or wrong, and here correct answer is option A, that is right. Next is question 73. The center of gravity of a trapezium with parallel sides A and B lies at a distance y from the base B as shown in figure. This is the figure. The value of y is, here friends these are the options, and option C is the correct answer for this question, that is h upon 3 into bracket 2a plus b upon a plus b. Next is the center of gravity of a right circular solid cone is at a distance of dash from its base measured along the vertical axis. Here option C is the correct answer, that is h upon 4. Next is The center of gravity of a right angled triangle lies at its geometrical center. It is incorrect, friends. So option B is the correct answer. Now next is question number 76. Match the correct answers from B to B for the statements given in group A. Now here, friends, first statement is center of gravity CG of a rectangle, and here, friends, option B is the correct answer, that is at intersection of its diagonals. Now next is CG of a triangle, and here option E is the correct answer, that is at intersection of its medians. Now next is CG of a circle, and here option A is the correct answer, that is at its center. Now next is CG of a semicircle. Here option C is the correct answer, that is at a 4r upon 3 pi from its base along the vertical radius. Now next is CG of a hemisphere. Here option F is the correct answer for this question, which is at 3r upon 8 from its base along the vertical radius. Now next is CG of a right circular cone. Here, friends, option D is the correct answer, that is at h by 4 from its base along the vertical axis. Next is the center of gravity of a quadrant of a circle lies along its central radius r at a distance of, here, friends, these are the options, and here option B, that is 0.6 r is the correct answer. Next is the center of gravity a T section 100 mm by 150 mm by 50 mm from its bottom is, here, friends, these are the options, and here correct answer is option C, that is 87.5. Now next is, friends, a circular hole of 50 mm diameter is cut out from a circular disc of 100 mm diameter as shown in figure. This is the figure. The center of gravity of the section will lie here, friends. These are the options, and here correct answer is option A, that is in the shaded area. Next is question 18. Moment of inertia is the, here, friends, these are the options, and here option D, all of these is the correct answer, that is moment of inertia is the second moment of force, moment of inertia is the second moment of area, moment of inertia is the second moment of mass. Now next is the unit of moment of inertia of an area is, here, friends, these are the options, and here option D is the correct answer, that is meter raise 4. Now next is the unit of mass moment of inertia in SI units is kg meter square. Here, friends, options are true or false, and here option A, that is it is true. Next is question number 83. A spherical body is symmetrical about its perpendicular axis. According to Routh's rule, the moment of inertia of a body about an axis passing through its center of gravity is, here, friends, these are the options, and here m is equal to mass of the body, and s is equal to sum of the squares of the two semi-axes. Here, friends, so correct answer is answer C. Option C is the correct answer, that is ms upon 5. Now next is 84. The radius of gyration is the distance where the whole mass or area of a body is assumed to be concentrated. It is correct or incorrect? So it is correct, that is option A. Next is question 85. Mass moment of inertia of a uniform thin rod of mass m and length l about its midpoint and perpendicular to its length is, here, friends, these are the options, and here correct answer is option B, that is 1 upon 3 ml square. Next is mass moment of inertia of a thin rod about its one end is dash the mass moment of inertia of the same rod about its midpoint. Options are same as twice, thrice or 4 times. So here friends, option D, that is 4 times, is the correct answer for this question. Now friends, here next is moment of inertia of a rectangular section having width b and depth d about an axis passing through its center of gravity and parallel to the width b is. Here friends, these are the options, and here correct answer is option B, that is b cube upon 12. Now next is moment of inertia of a rectangular section having width b and depth d about an axis passing through its CG and parallel to the depth d is. Here friends, these are the options, and here correct answer is option A, that is db cube upon 12. db cube upon 12. Next is question 89. The moment of inertia of a square of side A about an axis through its center of gravity is. Here friends, these are the options, and here correct answer is option C, that is a raised 4 upon 12. Next is the moment of inertia of a rectangular section 3 cm wide and 4 cm deep about x axis is. Here friends, these are the options, and here correct option is option C, that is 16 centimeter raised 4. Next is the moment of inertia of a square of side A about its base is a raised 4 upon 3. So it is true or false. So here correct answer is answer A, that is it is true. Now next is the moment of inertia of a square of side A about its diagonal is. Here friends, these are the options, and here correct answer is option C, that is a raised 4 upon 12. Now friends, here next is moment of inertia of a hollow rectangular section is shown in figure about x axis is. Here friends, this is the figure, and here friends, these are the options, and here correct answer for this question is option A, that is bd cube upon 12 minus small bd cube upon 12. Now next is question number 94. Moment of inertia of a hollow rectangular section is as shown in figure, that is this figure, about y axis is not the same as that about x axis. Here option A, that is it is yes, that is it is true. Now next is moment of inertia of a circular section about its diameter d is. Here friends, these are the options, and here option D is the correct answer, that is pi d raised 4 upon 64. Now next is moment of inertia of a circular section about an axis perpendicular to the section is. Here friends, these are the options, and here correct answer is pi d raised 4 upon 32. Next is question number 97. Moment of inertia of a hollow circular section is shown in figure about x axis is. Here friends, this is the figure, and here these are the options, and here correct answer is option D, that is pi by 64 into bracket d raised 4 minus small d raised 4. Next is moment of inertia of a hollow circular section as shown in figure. This is the figure friends, about an axis perpendicular to the section is dash than that about x axis. Here friends, option A is the correct answer, that is 2 times. Next is moment of inertia of a triangular section of base B and height h about an axis passing through its CG and parallel to the base is. Here friends, these are the options, and here correct answer is option D, that is bh cube upon 36. Next is moment of inertia of a triangular section of base B and height h about an axis through its base is. Here friends, these are the options, and here correct answer is option C, that is bh cube upon 12. So friends, in this part 2 of the video, we have seen next 50 theoretical questions and answers on engineering mechanics. Thank you friends for watching this video. Like, share and comment for this video, and subscribe my channel. Thank you.